Hello and welcome to this film, which is all about predicting pH. Now, this is a little bit different to calculating pH, but hopefully you've seen the films that allow us to calculate pH on the basis of H plus ion concentrations and OH minus ion concentrations. Here we're going to try and link those ideas with an understanding of what it means to be a strong or a weak acid, and we're going to hopefully see that the acidity or the basicity of a solution has got just as much to do with the concentration of a substance as it has to do with its strength. Now, here's nitric acid. Nitric acid is a strong acid. We should recognize it as being one of those three strong acids that we need to remember. We've got a solution that contains 0.1 moles in every dm cubed of solution. 0.1 of a mole of nitric acid has been dissolved in every dm cubed of solution. Now, you should be able to see from this equation and the fact that it's a strong acid which ionizes completely. If I take 0.1 of a mole of that, I should get 0.1 of a mole of nitrate ions and 0.1 of a mole of H3O plus ions. So in other words, my concentration of H plus is equal to 0.1 moles per dm cubed. So I can see exactly how acidic this solution is just by looking at the concentration of the acid. Okay, if the concentration of H plus is 0.1, then the pH is the negative log of 0.1, and that equals 1.0 to two significant figures. Okay, so I can calculate the pH of that solution because I know it's strong and I know it's monoprotic, and I've got the concentration of the acid. Here I'm given the concentration of the acid, but it's a diprotic acid. It's sulfuric acid. I know it's strong, and I might just say to myself, well, it's diprotic, so should the concentration of H plus be just twice that value? So should we have a concentration of H plus of 0.1 moles per dm cubed again, just like we did in the last case? There should be a question mark on the end there, you can't really see it. Well, the answer is no, it's not going to be that. Okay, and the reason for that is because if we take 0.05 moles of H2SO4, although it is strong and we will produce 0.05 moles of the hydrogen sulfate ion and 0.05 moles of H3O plus in this first reaction, and the hydrogen sulfate ion can react with more water and produce sulfate ions, the amount of H3O plus in the second equation, because this is weak, is going to be less than 0.05. Okay, so in other words, the total H plus ion concentration is going to be less than 0.1 moles per dm cubed. I can also say it's going to be greater than 0.05 moles per dm cubed, but it's hard for me to say exactly what the concentration of H plus is or how acidic this solution is, because I don't know the degree to which this one ionizes. So it's hard for me to say what the pH is. Okay, so this solution would be more acidic than a solution of the same concentration of nitric acid, say, which is monoprotic, but it's not going to be as acidic as this concentration of as a solution of that nitric acid that we looked at in the previous slide. Okay, so again, what we're seeing here is that the acidity is to do with not just the concentration, but to do with strength. Now let's look at a weak acid. Here we've got a solution with a 1 mole per dm cubed concentration. So if I take 1 mole of that and dissolve it in water, in 1 dm cubed of water, I will get a lot less than 1 mole per dm cubed of that, and a lot less than 1 mole per dm cubed of that. And roughly speaking, about 1 in 100 to 1 in 1,000 molecules of ethanoic acid will split up and form H3O plus ions. So let's just say that roughly the concentration of H3O plus is going to be 0.001 moles per dm cubed. This would mean that the pH would be roughly 3. In other words, the acidity of this solution is much less than the acidity of those two solutions we've just looked at, even though the concentration of the acid is much higher. And again, we can't put an exact value on the pH because we don't know the exact concentration of H3O+, but we're seeing again here that the concentration of the acid has got something to do with the acidity or the pH, but not everything to do with it. It's also got to do with whether your acid is strong or weak. The same can be said for bases. Now we know that potassium hydroxide is a strong base. We know that if we take 1 mole of it and dissolve it in water, we should get 1 mole of that and 1 mole of potassium ions. We now know the concentration of OH minus. The concentration of OH minus is equal to 1 mole per dm cubed. And we also know that the concentration of H plus multiplied by that is equal to 10 to the minus 14 because Kw equals 10 to the minus 14. And this must mean that the concentration of H plus is equal to 10 to the minus 14. Or in other words, the pH equals 14. So again, the acidity or the basicity of our solution depends not only on the concentration of the solution, but also on whether it's strong or weak. If this base hadn't been strong, it would have been very hard for me to calculate what the concentration of OH minus ions was, and I wouldn't be able to find the pH. Here's another strong base, but this time it's a different strong base. It's barium hydroxide. I've got a 0.01 mole per dm cubed solution of it. This means that I have dissolved 0.01 moles of this substance in every dm cubed of water. Now the concentration of OH minus here is going to be 0.02. So I can calculate the concentration of OH minus here is 0.02. I could even calculate the concentration of H plus, because this would be 10 to the minus 14 over 0.02. And then having found that, I could find my pH, because that's the negative log of my answer. Okay? We could ask ourselves, well, what's it likely to be roughly if we wanted to do a check, right? Well, if the concentration of OH minus was 0.01, then the concentration of H plus would be 10 to the minus 12. And the pH would be 12. But the concentration of OH minus is greater than that. So the concentration of H plus will be smaller than that. And the pH would consequently be higher than that. But as usual, we can plug these numbers into our calculator and find the answers so we can find these things precisely. But point being here that the concentration has got something to do with it, but we also need to consider, is the thing monoprotic, is it diprotic, can it give away more than one H plus ion or more than one OH minus ion, and is it strong or weak? Because without a knowledge of all those things, we can't really predict what the pH is going to be. Okay, so hopefully that all makes sense. Hopefully you can see how not only strength and weakness, but also concentration of substances will have a very, very important bearing on the pH of their solutions. If you've got any questions or comments, then please feel free to come and see me or to post a comment on YouTube.